Hi everybody, welcome to another iZet DWF arcade repair video. Today I'll show the repair process of this old Phoenix arcade PCB. It looks quite dirty, but overall it's not in too bad conditions. This is one of the games I'm looking for, as I played it quite a lot when I was a boy. Phoenix is one of the few games using the Intel 8085 CPU, which is an improved version of the 8080, and it was introduced a few months before the Zilog Z80, or, in other words, too late. Another interesting feature of this game is the use of the MN6221 Melody IC to play some music at the beginning of the new levels. One of the first things I did when receiving the board was to dump the ROM contents. It actually had a Pleiads game ported to the Phoenix original hardware. However, since this is one of my wanted game PCBs, I had previously studied the service manual and other PCB pictures online. As we can see in the service manual, the game PCBs have the TIM 8001 and TIM 8002 codes. And the same codes are clearly visible in the board set I've got, so I was quite sure these were a Phoenix board set. However, this board set, even if original, was probably populated in Europe, because some components are clearly made in European countries, like the German blue electrolytic capacitor in the center of this picture. Other than needing a very good cleaning, this board set suffered the usual bypass capacitor mechanical death. This usually happens when these old boards are stacked one above the other and handled without much care. Here's another one that is now missing a lot of the original capacitance value. So all broken bypass capacitors have been substituted with new ceramic ones. Then another missing part was the audio loudness trimmer. Also, this one was replaced with a suitable spare. Then another damaged capacitor has been spotted in one audio effect filter. Now I believe this circuit works better when these two capacitors are closely matched. So I have substituted both with two identical film capacitors that are better suited for audio circuits than the cheap ceramic ones. Then I started inspecting the solder side, and I've spotted this solder joint that appears to have never seen any solder, so after probably 44 years it was finally soldered. Some other solder joints looked a bit clumsy, in particular under the flat cardboard connectors, so I've took some time to reflow the worst ones. Then I checked all electrolytic capacitor as usual with the SR meter and found a couple of them showing a bit too high resistance. The LCR meter agrees about the dissipation factor being too high in fact. Now, since the tantalum capacitor is part of an audio effect circuit and since its value is small enough, I've decided to replace it with a non-polar film capacitor. This will likely last forever or almost. Finally, it's time to wire an interface connector for power supply and all other needed signals. However, the PCB edge sides were kept too narrow and the connector can easily be mated shifted enough to have the fingers contact between the pads. So I cut an edge connector pad from a donor board that I kept for spare parts. Then I sanded it on both sides until it fitted nicely on the edge key with the right distance from both the pads next to it. At this point I mated the connector to the PCB edge, aligning the contacts as precisely as possible, and then soldered the additional pad to the connector itself. In this way, we obtain a keyed and self-aligning edge connector. The added pad has been sanded a bit to allow the connector to be fully inserted, so all is now ready for the first power on. Well, we have a completely black screen and some sounds playing continuously, but at least I haven't seen any smoke. So, as always, the first thing to check is the CPU clock input. On the 8085, the external clock input is on pin 1. And yes, this is a good clock signal. Now, another good thing to check is the ROM address decoder, the 74LS138 in position IC10. Well, this is strange. The decoder inputs seem floating. And in reality, all the CPU address pins look also floating. So I've decided to try a spare CPU that is surely working. However, nothing really changed. I seem to remember, however, that the 8085, unlike some other 8-bit CPUs, can restate the address bus. In particular, as we see in this table, this can happen if the CPU executes a halt instruction. Also, this game PCB only has a power on reset circuit and no watchdog to reset the CPU in case it gets stuck for some reasons. So maybe a fault somewhere is making the CPU get the halt opcode. To prove this hypothesis, I'm going to connect a wire to the reset pin and try to reset the CPU manually. All addresses look floating as before. Let's ground the reset momentarily. And yes, there is some activity, and then it dies again. Since the CPU isn't executing the correct code, one place to start looking for possible faults is directly on the code EEPROM pins, either address pins or data pins. So I'm first checking the lower address pins. This one looks floating. Also, this low one doesn't look good. But yeah, this one is floating. Now, pin 3 of all code ROMs is connected to address line number 5. Since the 8085 has a multiplexed data bus with the lower address bits, then it needs an address demultiplexer. Here this function is accomplished by the 74LS374 in position IC2. Notice that it has its output enable pin permanently grounded, so all the outputs must be driven high when the CPU halts, because all its inputs will go floating. So let's check some of its inputs and output pins. So, having found at least 2 bad outputs, I replaced the 74LS374 with a new one. Now we have activity on all address lines, so the CPU is not getting stuck anymore. However, there are always the continuous sounds and a completely black screen. So let's see how the video output circuit works on this game. Like on most other games, the 3 color signals are obtained by combining the outputs of some color prompts with a simple resistor weighted DAC. In this case, there are 2 color prompts, each contributing 1 bit to each color, plus an open collector buffer IC before the resistors. Of course, the 2 prompts were dumped initially together with all the EEPROMs, so I'm sure they are both good. It must be then something bad in other places. Let's check the address inputs on the prompts. it seems everything is stuck low. The inputs of both prompts are driven by a 74 LS174 register, so I'm going to see what happens there now. Well, for sure, pin 1 is low. Pin 1 of the LS174 is the active low reset, so it's indeed correct that all its outputs are low if the reset is never lifted. So I started checking the ICs that generates the register reset signal. These are IC 14, 26 and 27. But after a quick check, I've realized that most of the vertical address bits coming from the RAM-ROM PCB were never toggling, so this must be the real problem. The vertical address bits, like in most other games, are generated by a series of cascaded counters. In this case, we have a couple of 74 LS163 in position IC12 and 13, so let's check them. I'm checking the outputs from pins 11 to 15. IC12 looks good. But IC13 have stuck beads. Only pin 15 toggles. Now, pin 15 toggling and pins 11 to 14 stuck high isn't possible on a working 163 counter, so I've removed the old one and installed a replacement. I have also relocated on the solder side the capacitor that was originally soldered on top of IC13. Now all the outputs are toggling as expected. And we have an image, but the game is not yet starting. When we have a board that looks very dirty and also has sockets of very low quality, like the ones circled in red that have contacts only on one side of the pins, then it's always worth pulling all socketed ICs and reinsert them, even if I really did this operation once when dumping the EEPROMs and checking the RAMs. And the game this time started fine, even if we still have the continuous sounds playing. All the various sounds are toggled on and off by the main CPU by writing the appropriate data bits on these two 74LS374 8-bit registers in position IC5 and 6, so I'm going to check the output of both ICs. And here we have a floating output. That's surely bad. So I pulled the old IC6 and installed a replacement LS374. And of course now all outputs are correctly driven, but we can still hear a continuous noise. Now, since I didn't find any other good explanation, I wanted to check again the ROM dumps on MAME. And, as we can hear, flipping one dip switch enables this continuous noise in attract mode. So let's flip the actual dip switch. Yeah, that was it. Unfortunately, there's still something bad. Listen to this. It is a kind of oscillating noise and it's not so loud, but it's surely not normal. Now, if I place the logic probe on C17, the noise disappears. Of course, C17 was not chosen randomly. There are some capacitors that couple the activation logic signal to the analog effect generators. In this case, C17 goes to a 555 in position IC44. That is part of a 3-oscillator audio effect. Let's see what signals we have there. This is the output of IC50, which is the last oscillator in the chain, and as we can see it's pulsating exactly as the audio noise. Here we see the output of IC51, which is in the middle of the chain. This should give a square wave toggling at about 1 second interval, and I think it is okay. And going back, this is the output of IC44, and this has a quite dirty edge, and it's also oscillating too fast for the component values in this schematic. Pin 2 waveform is also bad. On the oscillating 555, this should be a triangular wave. In fact, just for confirmation, I've made the same oscillator circuit as the one comprising IC44 on the breadboard. The output on pin 3 is very clean and has the correct frequency. And pin 2, as expected, shows the quasi-triangular waveform. Before substituting IC44, of course I've checked that the timing resistors and the timing capacitor were measuring the correct values, but since they looked fine, I've just removed the old 555 and installed a replacement one. The pulsating noise disappeared. We have just the digital noise coming from the power supply, but this is with the volume trimmer at the maximum, so this is entirely normal. I remember seeing this game in the old days, but I think I only played it once and then decided there were better games to waste some coins for. Well, that's it. I think it's time to convert it back to Phoenix. So I've raised the EEPROMs and programmed them with the complete Century Phoenix binaries. One original TMS 2516 EEPROM could be erased completely, but didn't want to be programmed again. But I've got enough spares anyway. And here is the original game running on this board set. As far as I can tell, the attract mode is running fine. So I've started playing a few games. Unfortunately, the Commodore joysticks only have one button, so I wired the sheet contact to the up position and I am triggering it very often by accident. Well, the sound effect on this level is wrong, so the board still has issues. Also, the sound effect is not correct. And then, after a couple of hours, also the explosion and shooting sounds disappeared completely. So we have two separate issues now. Let's first try to understand where to look. The first thing I noticed were the wrong sounding audio effects on some levels. Those are controlled with this TTL counter IC. Then there was another wrong effect, but I failed to capture it on video. Basically, when the game starts, we hear the Romance d'Amour melody, played by this IC, but then if you kill the big mothership, the game starts again from the first level, and it's supposed to play the Fiorelisa melody, of course from this same IC, but with different input levels. However, in the only occasion I could kill the mothership, I heard again the Romance d'Amour. Now, both the wrong sounding effects are enabled using this 74LS374, which is the last original one in this CPU PCB. In fact, 2 out of 3 were already faulty, so I believe that even this one is bad, even if I didn't find any floating output like it was found on the other ones. Then the explosion and shooting noises disappeared. These are made with a classic shift register pseudo-random bit generator. This is composed by a CMOS 4006 shift register and an inverting exclusive OR feedback made with 2 gates. The shift register clock comes from a 555 square wave oscillator that is enabled by a transistor. This effect, however, is controlled by the other 74LS374 that was already substituted, so the noise generator itself must have failed in some other ways. First of all, I'm going to check the clock input to the shift register. I'm just firing randomly, but each time we can see the probe flashing, so the clock generator is working fine. However, the feedback taps of the shift register look always high. So I concluded that the 4006 CMOS shift register was faulty and I replaced it with my last working spare. However, that didn't fix the problem. The bad news is that I was too quick in concluding that the shift register was faulty, because it could even be that the feedback gates are bad and their output is stuck to the logic 1, and in this case all the shifter taps will be always 1. The good news is that I can now use the added socket to check which one of the 2 feedback gates isn't behaving correctly by pulling up or down the inputs of the first gate. So I've set one input high and the other low. The output is low, but that's wrong for the exclusive OR. It should be high. Now this is a 74LS136, which is the open collector XOR IC, and it was used very rarely. I've cut the output pin to see if maybe the following input is bad, and I don't really have to pull this IC. So again, one input high, the other low, but the output is still low, so it's wrong. The following input is okay. I didn't expect to have one LS136 spare IC, but eventually I found one in the unsorted TTL bag, so I didn't have to order and wait for a replacement. Of course, the original 4006 shift register has been put back in its old position. Let's see what happens. Yeah, the shooting sound is okay now. And the explosion too. Let's see if we can fix the other faulty sound effects now. As I explained before, the only likely reason for the other 2 sound effects failing is the LS374 IC that enables both of them, so I've just pulled the old one and installed a replacement. Let's play now some more games. And yeah, now it sounds correct. Let's compare the sound effects before and after the fix. So this board set is now fixed and I've kept it on the bench for a few days. It's all for this video. I hope it was interesting and that you learned something. If you have any question, please use the comment section below. Have a nice time and thank you for watching.